Okay, rolling through. Next video here, we've got Unit 2 review number 21 through hopefully 27 at least. That'll end this segment. So as we look at 21, tangent of negative 270, again, sorry about that. What we're looking for is, number one, to make sure we're drawing this 270 degrees backwards. So that's negative 90, negative 180, negative 270. There you go. So tangent of that negative 270, tangent again, tan, is equal to the opposite, which is our y, over our adjacent, which is our x, anytime we draw a triangle. And when we look at the y value, the vertical, that opposite, that's the sine value, and x is our cosine value. So if we look at that, x comma y, 0 comma 1 is also our cosine comma sine. So if we look at doing this tangent ratio y over x, that's 1 over 0. So that, my friends, is a big fat DNE. Does not exist. There is no ratio there. There's no value. So 21 done, check. All right, moving on. 22, here we go. Now we're starting to do what am I talking about? Inverse trig functions. So secant of 5 pi over 3. This is where I need to just simply clarify, because I had lots of students asking. I had students that had all sorts of creative ways of solving this, including saying, well, if secant is the inverse of cosine, then is this asking me to find cosine of 3 over 5 pi because we flipped the fraction? And the answer is no, it is not the same. That is not the same. Okay, what we do want to do instead, the way I recommend you approach this, is we first recognize that secant is in fact the inverse of cosine. And what I want you to do first, step 1, is solve cosine of that same angle, 5 pi over 3. Okay, so let's do that. Solving cosine of 5 pi over 3. Cosine 5 pi over 3 puts us, well, there it is. Let me erase that. Puts us in the fourth quadrant, and we're solving for cosine. Let me make sure I'm doing this right. Yep, we're solving for cosine 5 pi over 3. There it is. Cosine refers to the x coordinate. So x is positive, but it is 1/2. So cosine, that's 1/2. Step 2 is invert. And all I'm saying is to flip your fraction. So 2 over 1. So your answer is just 2. Simple as that. Let's follow that same process for number 23. Cosecant of 5 pi over 6 is really like saying, step 1, solve sine of 5 pi over 6, right? Cosecant is the inverse of sine. So sine of 5 pi over 6, that's over here. Sine being our y value, so there it is. So step 1, we said that's equal to 1/2, and then step 2, we invert that and we put it as 2 over 1, and we come out as the same answer. So question 22 and 23 do happen to have the same exact magnitude, same value, although they're completely different problems. So let's keep going. Cosecant of pi over 4, we're going to first solve sine of pi over 4. Sine of pi over 4, by now you should have it memorized if you're this deep into this assignment. But sine pi over 4, here's pi over 4, right here. Sine is the y value, so our answer is 2. Step 2, we invert that and say 2 over the square root of 2. By the way, that is also equal to just the square root of 2. Let that sink in for a second. Because it took me the longest time, I don't know why, maybe it takes everyone else no time at all, but writing 2 divided by the square root of 2, plug it in, try it, pause the video, plug in 2 divided by square root of 2, and then come over here and also type in just the square root of 2, and you get the same answer, 1.414, blah, blah, blah. I don't know. To me, it was kind of one of those weird, mind-blowing, how can those two things be the same? But they are. So, anyways, we're going to move on. Oh, sorry, I could also box that in. There you go. 25, secant of 7 pi over 6. Let's see, so secant is cosine 7 pi over 6. What is the cosine of 7 pi over 6? Well, 7 pi over 6 is right here. Cosine is this first value, so that's the negative square root 3 over 2. So if cosine is negative square root 3 over 2, then the secant is flipped, and we get negative. We still keep the negative if it's there. 2 over square root of 3. And you guys, that's it. Like, you can box that in. There's no rationalizing that. There's no anything crazy with it. You just simply box that in. 26. 26 is the cotangent, 120 degrees. Cotangent, so let's look at 120 degrees. We're looking for the tangent. $120 puts us in that second quadrant. Where are we at? Ah, there we are. So we're looking at 2 pi over 3, or 120 degrees. We want the tangent value first. Now, this one here, if you want, you can find the whole tangent situation. It's kind of lengthy because you have to take like one fraction divided by another and then flip it. Let's do that first. So if we're going to do this following the exact same steps I told you to do for the rest of these, we need to find the tangent of this angle. We need to find what square root 3 over 2 all over 1/2 is, which is really, instead of multiplying by half, or dividing by half, we're multiplying by 2. So we get square root of 3. So if tangent is square root of 3, then cotan is going to be 1 over the square root of 3. Now the other way to do this is one of those tangents you don't have to follow that whole process. And the reason is, instead of taking and dividing y over x, you can shortcut all of that work and just simply reverse it and say x over y. You could do this and just say, oh, well, that's, I need to be careful. I missed this negative sign here, this negative sign here. Okay. And therefore the negative sign there. All right, so moving on, the other way we could have done this, it's a little bit shorter, not a whole lot, would be to take x over y, so negative a half over square root 3 over 2, which is equal to negative a half times 2 over square root 3, which equals negative 1 over square root of 3. So that allowed me to not have to do the whole flip the fraction after I solve it. But no matter what, cotangent is negative 1 over the square root of 3. Box it in. So again, I hope that made sense. If we follow the same process as always, we would take the opposite over adjacent. So the opposite being the y value, adjacent being the x. So square root 3 over 2 divided by negative a half. And that's what I did over here on the right. That gives you negative square root of 3, and then again, step 2 of my process, once I solve for tangent of the given angle, which in this case was negative root 3, the last step is to flip that fraction. Well, it wasn't a fraction exactly, it was, but it was negative root 3 over 1. So the other way to do that, in tangent only, you can take the x coordinate divided by the y coordinate and be done. All right, moving on, our last one in this section, cotangent, 765 degrees. Okay, wow, that's a lot. 765 degrees. So I'm just going to go tippy tab, calculator. I'm going to say, okay, well, 765 degrees, that's at least, there's 360, right? Well, I'm going to keep going, 360 plus another 360, that's 720. So if I take off 720 degrees from that rotation, 765, I see that I've gone 360, I've gone 720 plus 45 degrees. So again, there's my angle. Let me erase all of that. Okay. The other, again, you guys, the other giveaway is when there's a 5 at the end. It's not going to be a 30, it's not going to be a 60 reference angle, because both of those end in 0. So there's no way for that to magically get turned into a 5. So I could have told you right away, our reference angle is 45. The question is just simply what quadrant, so I know whether or not my answer is a positive number or negative. So 765, that really just puts us right back in quadrant 1. Tangent of 45, so again, step 1, take tan of 765. And tangent of 765 is the same as tangent of 45 degrees. And what we get is just root 2 over 2 divided by root 2 over 2. So that number is just 1. And then we can take the cotangent of that, which we take 1 over 1 and flip it, we still get 1 over 1. So there you go, that's 27. And stopping the video here, plenty of information. Plus 28 to 35, or 36, sorry. That's a different kind of question. Instead of being given the angle, find the ratio, they're telling you the ratio and you need to find the angles. So we will stop there.